Okay. Multiple integral 1. The topic is multiple integral of 1. So, definition of integrals. The concept of integral, the concept of integral, integration a to b f of x dx. Is equation 1 is physically the area under a curve y is equal to f of x. Say the x-axis. And the two ordinates x equal to a and x is equal to b. It is defined as the limit of the sum. So for example, this is the x-axis, this is the y-axis. So x equal to a, the line is parallel to y-axis. This is the x is equal to a, the line is parallel to y-axis. X equal to b, the line is parallel to y-axis. So this is called x-axis, 0, y-axis. This is equal to x is equal to a straight line, x equal to b straight line. Y equal to f of x is the curve. So the curve, maybe this one, curve. Y equal to f of x is curve. Okay, this part is called, area. This is part is considered area. Okay. This part is considered area. Okay, this is the meaning. Okay, so f of x1 is what it is, f of limit of the sum, f of x1. So first of all, integration f of x1 delta x1 plus integration f of x2 delta x2 plus and so on, integration f of xn delta xn. So apply the both limit when n tends to infinity and so on, n tends to infinity, and each of the length, this is the limit n tends to infinity, that is the meaning. Each of the limit length so delta x1 comma delta x2 and so on delta xn tends to 0 and tends to 0. Here delta x1 delta x2 and so on delta xn are n subdivisions, small n subdivisions into which the range of integration has been divided and write down continue next step and write down and x1 comma x2 x1 comma x2 and so on xn are the values of x lying respectively in the first, second, and so on nth subintervals. Okay, the formulas. What are some formulas? Integration formula. So integration 1 dx, that is the value x. Integration dx x. Integration x dx x square by 2. Integration x square dx x cube by 3. Integration x power n dx x power n plus 1 by n plus 1 plus c. Integration 1 by x dx log x. Integration log x dx x into log x minus 1 plus c. Integration root x dx 2 by 3 x power 3 by 2 plus c. Integration 1 by root x dx. So 1 by 2 root x plus c. So 2 root x plus c. 2 root x plus c. Okay, 2 root x plus c. integration a power x dx, a power x by log a, integration e power x dx, e power x plus c. So this is the most important formulas. Next, trigonometric formulas. Integration sin x dx minus cos x, integration cos x dx, sin x plus c, integration tan x dx, log of secant x plus c, integration cot x dx, log of sin x plus c. Okay, right. Continue next step. Integration secant x dx, log of secant x plus tan x plus c, integration cosecant x dx, log of cosecant x minus cot x plus c. So very important. Integration secant square x dx, tan x plus c, integration cosecant square x dx minus cot x plus c. Okay, next integration 1 by root of 1 minus x square, inverse trigonometric function, sin inverse x. So very most important, 1 by 1 plus x square dx, tan inverse x. Okay, very important. Remaining write down. Write down. Next, double integration topic. So double integration, integral, double integral. A double integral, a double integral is the counter part of the above definition. Above definition in 2 dimensions. Let f of x comma y be a single valued unbounded function of two independent variables x and y defined in in a closed region, capital A, in XY plane, in XY plane. So please observe the diagram. XY plane means graph. A double integration is counterpart of the above definition in two dimensions. F of x comma y is single valued and bounded function. So this is represent area one consider. This is the area. This is the area and single valued and taking the delta A part, some part. So two independent variables. So two dimensions. So this area is find out. So this whole part. So f of x1, y1, delta a1 plus f of x2, comma y2, delta a2. And so on. F of xn, yn, delta an. So this is right as summation r is equal to 1 to n f of xr comma yr delta ar, equation 2. So then the limit of the sum, equation 2, it exceeds as n tends to infinity, and each and sub-elementary area approaches to 0 in termed as double integral of f of x over the region A and expressed as so denoted by double integration. Simply is find out area, simply denoted area f of x comma y delta a or dA, simply dA. Area is finally find out. Okay. Thus, write down, continue next step. So thus, double integration A. So double integration means simply find out area f of x comma y dA or delta L. Limit n tends to infinity. F of xr comma yr delta AR. Equation number 3. N tends to infinity means delta AR tends to 0. Next, evaluate. Double integral. Evaluation of double integral. Double integral. So double integral or f of x comma y dx dy is discussed under the following three possible cases. So case 1. When the region capital R, please observe how to evaluation. When the region capital R in bounded by two continuous curves y is equal psi of x, that means psi of x, two curves, and y is equal pi of x, two curves, and the limits means coordinates, x coordinate or y coordinates. X is equal to a coordinate and x is equal to b. Now that means limits also. In such a case, integration is first performed. Integration is first performed with respect to keeping like keeping with respect to keeping so y keeping x constant, y keeping y అంటే y వేరియబుల్ తీసుకుంటే x అనేది కాన్స్టెంట్, x as a constant, y keeping x as a constant, treat as constant, and then resulting integral is integrand within the limits x is equal to a and x is equal to b. Right now, next draw the diagram. Okay, draw the diagram. So this is the x-axis. So please observe, this is the x-axis, y-axis. This is two curves, x equal to a, one line, x equal to b. Two curves is here. So one rectangle region is formed, A, B, C, D. So when the region capital R, this is a region, capital R is bounded by two continuous curves, y equal to psi of x and y equal to pi of x, the limits x equal to a, and in such case, integration is first performed with the to y keeping. So first, so what is the integrand first keeping? So this is the find out one rectangle. So PQ. So this is the area. First find out this area and next find out this area. So mathematically expressed as so double integration or f of x comma y dx dy is equal. So first integration x is equal to a, x is equal to b, and next integration y is equal curve pi of x, psi of x, y equal to psi of x. First y keeping, that means f of x comma y dy, and next to find out the integration dx. First treat as this one and next time treat as again dx. Okay, this is a definite integrals. Right now, next case 2. Case 2 problem. Case 2. Then the first region capital R. Please observe the diagram. First region capital R is bounded by two continuous curve. Please observe the curve. Continuous curve. So x equal to, curves are not y equal to, x equal to pi of y and x equal to psi of y. And the two lines abscissa. Abscissa means parallel to x-axis, y equal to a and y is equal to b. So y equal to a is parallel to x-axis, y equal to b is parallel to y-axis. In such case, integration is first. Integration is first performed with respect to x. Respect to x. First performed x, keeping y as a constant, and then the resulting integral is mathematically expressed as double integration or f of x comma y dx dy is equal integration x is equal to not y is equal, x equal to pi of y and x equal to psi of y. So integration. So next is consider y is equal to a and b. F of x comma y dx. First perform dx and next perform dy. So is write as different terms. First integration write as y is equal to a to b integration x is equal to pi of y, x equal to psi of y. First we have evaluate x integration, y is a constant. So diagram. X-axis and y-axis. So draw x y is equal to a is parallel to x-axis. Y is equal to b also parallel to x-axis. So two curves. This is one curve. This is another curve. This is x equal to pi of y, x equal to psi of y. This is x is equal or y is equal to, sorry, y is equal to b, y is equal to a. This is two straight lines. So one rectangle region is find out. A, B, C, D is find out. So between the area. PQ. So this part is find out. And then this part is find out. Next. So generally, the process is shown in the figure where the integration carried, where the integration is carried out from inner rectangle, from inner rectangle. Next, last one. Case 3. Write down case 3. When the both pairs, when the both pairs of limits are constant, limits are constant, some S. The region of the region of integration is the rectangle ABCD. Draw the diagram. X, Y, first X equal to, so region. First X equal to A straight line and X equal to B straight line. Next, Y is equal to A and Y is equal to B straight lines. Draw the first these two triangles. So all are intersect and the region is find out. This part region and this part region. Finally, this part is find out. Final A, B, C, D. P, Q, R, S. In this case, it is immediately whether f of x comma y is integrand first with respect to x or y, anyone, you choose anyone. The result is an alt way in both the cases. So both cases are same. Next, properties. Double integral. Properties of double integral are similar to those of definite integral. Let f and g be two continuous and single valued functions of x and y. Within the region capital R, then the first one integration or f plus h, f plus g, dx, dy. I will write first of all double integral f dx dy plus double integral g dx dy. Okay, write down. Next formula. Second one, double integral or k is the constant, k f dx dy. K is the constant, double integral of or f dx dy, where k is constant. Third one, double integral or f dx dy, integral of r1 f dx dy. It's double integral of r2 f dx dy, where r is the disjoint set of where capital R is disjoint union of R1 and R2. So region integration next topic. Region of integration. If the region of integration is a rectangle between the lines x equal to a, x equal to b, y is equal to c, and y is equal to d, then double integration or f of x comma y dA is equal integration a to b integration C to D f of x comma y capital no problem. Dx dy is equal to integration C to D integration A to D f of x comma y dy dx. So this is also case 3 now. Case 3 method. Okay. So both are constant. Limits are constant. Integration with respect to x or with respect to y. So going to problems.